Ah, Hi students, today we will continue our chapter waves. In the previous class we have derived the equations for speed of transverse wave and speed of travelling wave and superposition principle we have discussed. Today we are going to discuss speed of longitudinal wave. Okay, speed of longitudinal wave. So longitudinal wave, best example for longitudinal wave is sound wave. Okay, sound wave is propagating in which medium? Air medium. So that will be propagating in the form of compressions and rarefactions. Compression is high density and high pressure region. Rarefaction is low density and low pressure region. Like this. This region is rarefaction and this region is compression. And this rarefaction, compression. The distance between two immediate compressions is wavelength, and the distance between two immediate rarefactions also wavelength. So when sound wave is propagating in the medium, particles of the medium vibrate parallel to the direction of the motion of the direction of motion of direction of propagation of the wave. Direction of propagation of the wave. This is the direction of propagation of the wave. So to that direction, particles of the medium vibrate parallel and getting compressions and rarefactions. Okay. For speed of the longitudinal wave, medium plays an important role. Speed of longitudinal wave depends on properties of the medium. Properties of the medium, as we discussed in speed of transverse wave on string. How that speed is depending on nature of the string, like that. For longitudinal wave also, speed of the longitudinal wave depends on nature of the medium, properties of the medium. Inertial property of the medium. Inertial property of the medium is density of the air. Okay, density of the air. Inertial property of the medium is density. Okay, and if we take one compression, in this compression pressure is very high. Okay, and density also very high. If pressure is high, then all the particles are coming nearer to each other, At that time, immediately another property is making all the particles move away from each other. That property is elastic property of the medium. Okay, that elastic property here in this case is bulk modulus. Bulk modulus is elastic property. Bulk modulus in any region in compression is, if pressure applied is delta P, increase in pressure in the compression region is delta P, and because of that volume decreases by delta V divided by V. So this is bulk modulus B. Okay, so B can be written as, that means bulk stress divided by bulk strain. V delta P minus divided by delta V. This is bulk modulus, and this is density of the medium. So now speed of the longitudinal wave depending on density and bulk modulus. Now we are going to get the relation among these three physical quantities by dimensional analysis method. Okay. So dimensional analysis method is very useful. We have learned that in units and measurements. Okay. See, V proportional to density and bulk modulus. So V is equal to one constant, proportionality constant, it will be C, rho and bulk modulus. C value is equal to 1. It depends on the nature of the medium. And V dimensional formula m power 0, L power 0, T power L power 1, T power minus 1. Okay. C value I am taking 1. Okay. And density, you know that mass divided by volume m power 1, L power minus 3, T power 0. Here I write it as rho power A and B power small b. Okay. As unknowns. And bulk modulus SI unit is Newton per meter square, that is nothing but force per unit area. That means m power 1 area divided by area means L square, that if it comes to numerator L power minus 2. Okay, T power minus 2. Okay. See, force m L T power minus 2 divided by L square, so it will be L power minus 1. Okay. Now m power 0, L power 1, T power minus 1 is equal to m power 1 into A, m power A, L power minus 3A. Okay. And T power 0, m power B, L power minus B, T power minus 2B. Now you can add the powers, bases are same. M power A plus B, L power minus 3A minus B, T power minus 2B. Left side m power 0, L power 1, T power minus 1. Both sides powers are bases are same, you can equate the powers. A plus B is equal to 0, equation number 1. Minus 3A minus B is equal to 1, equation number 2. And minus 2B is equal to minus 1. 1 get cancelled. This is equation number 3. From equation number 3, B is equal to 1 by 2. And if you substitute in any first and if you substitute B value in any one equation in 1 and 2, you will get A is minus 1 by 2. And that we will substitute in this equation without C value. V is equal to rho power A, in the place of A minus 1 by 2. In the place of B power 1 by 2. So V is equal to square root of B divided by rho. This is the speed of longitudinal wave. Longitudinal wave speed is equal to square root of bulk modulus divided by density of the medium in which longitudinal wave is propagating. So here we got the equation for velocity, speed of longitudinal wave. Okay. Remember, speed of the longitudinal wave we can write in other form also, square root of V by rho. If longitudinal wave is propagating in air medium, A bulk modulus divided by density of the air. Okay. Suppose if longitudinal wave is propagating in ideal gas, if longitudinal wave propagating in ideal gas, you know ideal gas equation, for n moles PV is equal to nRT. PV is equal to nRT, pressure, volume, number of moles, gas constant and absolute temperature. Okay. Here this at a constant temperature, if you take this longitudinal wave propagation is a isothermal process. If wave propagation is isothermal. Isothermal means you know that T remains constant, temperature remains constant. If temperature remains constant, so how this equation is changing? If you differentiate this, then you will get T delta V plus V delta P is equal to 0. You can differentiate this with respect to time by you can use UV method. Pressure and volume are both are varying and remaining three are constants. Okay, so these two things are variables. P into differentiation of V plus V into differentiation of P is equal to 0. This divided by dt will go to other side, it becomes 0. Okay, now P delta V is equal to, you send this to other side, minus V delta P. So P is equal to minus V delta P divided by delta V. This is bulk modulus. So already we know that this is bulk modulus. So in ideal gas, pressure only, bulk modulus. Pressure only, bulk modulus. So what is the speed of the longitudinal wave in ideal gas? P by rho. This equation is called the Newton's equation of longitudinal wave. Okay, but mathematically this will be giving a wrong value for the speed of wave, speed of longitudinal wave. So we have to correct that equation. So Laplace has done that correction. So Laplace correction for the Newton's equation. Newton's equation for speed of longitudinal wave is E by rho. Newton has derived this equation by assuming the propagation of the longitudinal wave in ideal gas is an isothermal process. Isothermal process means temperature remains constant. And he assumed that at every compression and rarefaction, temperature is constant. Okay, but temperature, because of the rapid movement of these compressions and rarefactions, temperature doesn't remain constant. Heat remains constant. Heat remains constant means that process is adiabatic process. So according to Laplace, propagation of longitudinal or sound wave in ideal gas is adiabatic process. Adiabatic process. So delta Q is equal to 0. Change in heat energy is 0, that means heat remains constant. So then you will, if it is adiabatic process means adiabatic process equation is PV power gamma is equal to constant. And if we differentiate this on both sides, constant differentiation 0, and again UV method here, divided of P into V power gamma is P, and differentiation of V power gamma is gamma into V power gamma minus 1. You know that d by dx of x power n is n into x power n minus 1 into d by dx of the base dv. Okay, dv plus V power gamma is constant and remains same, and P differentiation is dp, that is equal to 0. So shuffle this. That means if you send this term to other side, P gamma V power gamma minus 1 dV is equal to minus V power gamma dP. Okay, and this P gamma V power gamma V power minus 1 dV is equal to minus V power gamma dP. V power gamma cancel, and then you will get from this P is equal to the send other terms, this remaining terms to other side, dP divided by dV. V power minus 1 will come to here if it goes to numerator V, okay, and gamma, here gamma, okay. Now P is equal to V dP, so here minus is the minus, this is B, that means pressure, one second, minus V dP divided by V. So P is equal to, this is bulk modulus divided by gamma. So now bulk modulus is what? P times gamma with negative symbol, okay. Now bulk modulus is P times gamma. So in Laplace equation, the same equation is corrected by Laplace, that is equal to V square root of P is replaced by that means bulk modulus is replaced by P gamma divided by rho, okay, gamma P by rho. This is the equation for the speed of longitudinal wave given by Laplace, and this will give exact numerical value for the speed of the sound wave in air medium or in any isothermal, that means in any, if you take the medium as ideal gas, there also you get correct values. Okay, next we will do some problems based on progressive wave equations and how to calculate different characteristics of the progressive wave. Okay, first problem number 1. A progressive wave of frequency 500 Hz and speed 360 meter per second is propagating what distance apart by particles of 60 degree out of phase. Okay, 60 degree out of phase. Progressive wave frequency is given 500 Hz. Okay, and speed of the progressive wave is given as 360 meter per second. And the two particles are having phase difference. Suppose this is one particle and this is one more particle. The distance, that means phase difference between the two particles is 60 degree. What is the distance between them? This is the distance, delta x. So if you know the phase difference, you can calculate path difference. So what is the relation between phase difference and path difference? Phase difference delta theta is equal to 2 pi by lambda times path difference. Okay. Now we want path difference. Delta x is equal to lambda delta theta divided by 2. Delta theta is how much? 60 degree. 60 degrees in radian, pi by 3. To convert degrees to radian, pi divided by 180. Okay? Multiply with pi divided by 180. Then you will get pi by 3 radian. Then lambda by 2 pi into pi by 3. Pi get cancelled. Lambda by 6. Lambda by 6. So from these two values we will get lambda. You know that V is equal to F lambda. Lambda is equal to V by F. V is 360 divided by 500. 0, 0 cancel. So lambda can be written as 36 by 50 into 6. 6 1 there, 6, 6 there. 6 divided by 50. So how much it is? 0.1, and it will be 0.12. Okay. Delta x is 0.12 meter. This is the distance of separation of two particles which are having phase difference 60 degree. Next, we will see one more problem. Problem number 2. A longitudinal progressive wave equation. A longitudinal progressive wave equation is y is equal to y of x comma t is equal to 5 into 10 to the power of minus 2 sin pi 400t plus x. All physical quantities t, x units are in SI units. Find first question in this frequency. Second question velocity and acceleration at x is equal to 1 by 6 meter and t is equal to 0.01 second. Third question maximum velocity and maximum accelerations. These three we have to calculate from this longitudinal progressive wave equation. So first of all we have to compare the given equation with the standard progressive wave equation. We know that standard progressive wave equation y is equal to y of x comma t is equal to a sin omega t. So plus is there. So if plus is there, the wave is going along negative x axis. We have discussed already. Plus kx. Okay. Now a sin 2 pi by t. You can write omega as 2 pi by t small t plus 2 pi by lambda. Propagation constant is 2 pi by lambda into x. So here you can take pi outside. Sin pi 2t by capital T plus 2x by lambda. This is the standard equation. So this given equation and the standard equations are in similar form. Now we can compare. In the place of A, 5 into 10 to the power minus 2 is there, amplitude is A, okay, 5 into 10 to the power minus 2. And in the place of 2 by capital T, 400 is there. 2 by T is equal to 400. So it is 200. 1 by T is 200. F is equal to 200 Hertz. F is equal to 200 Hertz. Okay. Frequency we have calculated. Velocity and accelerations, maximum velocity, maximum accelerations will be calculated in the next video. Okay.